Thank you for joining this session. And I'm Valerio Barbera from Italy, and I'm really grateful to have the opportunity recently to go in these kind of amazing conferences and events all around Europe to share this amazing story. Because what I found working on this open source framework, this open source project, Neuron AI, that I'm going to share a lot of details with you, is really an ecosystem story of the status quo of the PHP ecosystem. And everything started in the beginning of 2024, when basically the AI story, become quite mainstream, and we as software developers, we were rapidly switching from just experimenting with this kind of technologies and systems as user to using this technology to power our application, to experimenting with this infrastructure, AI, to create a completely new kind of software of applications. And for quite some times, everything about this new architecture, new technologies, spoke just one language. That was Python, LangChain, LangGraph, nothing else. And this is a language that I never spoke. A table where basically we as PHP developers, but it's also a problem that faced other ecosystems like Java, for example, Ruby on Rails. This was a table that none of us was invited to. It was just Python. Personally, I looked at this change from the perspective of a CTO of a product company. My company was entirely built around the PHP stack. So I'm a PHP developer. And as a product owner, as a product guy, it doesn't matter what technology are you using to build your products, your application, because the competition is across the board. Other developers, other companies working in other technologies, they can build exactly the same product you have, but what they are able to do depends by the ecosystem that powers the programming language, the underlying technology. And in my case, the fear was the real feeling I felt. Start looking at this shift toward the Python ecosystem. And as a PHP developer, I started really, to be concerned because without any tools, I started to be interested to work with AI, not as user, but to build software, to build applications powered by these technologies. And as a PHP developer, I didn't find anything. Zero tools, zero developer tools, zero architecture, nothing that can help me to start playing and experimenting with these technologies. So this was the reality I was facing. And the fear was because without any of these, developer tools or support in general, it was at risk the existence of my company itself, or even me as a PHP developers, because the entire software development ecosystem was shifting towards something that PHP developers was completely silent to. And, for me, it was really this concern that drove my action, because it was an unsustainable path to think that tomorrow morning I can throw everything away of my decades of skills, decades of tools, of assets, and just start working on Python because I have to out this new opportunity of building software with these new technologies. And the situation was that in PHP, there was just two tiny libraries, if I can say. One was the Prism SDK, that it's a library that lives only into the Laravel ecosystem. It was just a wrapper around the provider, AI provider, APIs, just a couple of them. And another library was LL-Font. I think this is the right way to name it. That was really just like a library, not a cohesive SDK, so it was really tough to create, these entities that works like an agent. And in my mind, the real problem was the missing of a complete cohesive architecture that act like a framework. I started to thinking about in the framework way, because looking and learning for about 1 year, even more, 1 year and a half, I understood that there are a lot of new technologies, patterns that you have to follow to create this kind of backend, this kind of new applications, like the LLM, that is the cognitive engine behind this kind of agentic systems. There are all the components for these new retrieval augmented generation, so vector databases, completely different technologies than any other normal database we are used to use. There are all the infrastructure that powers these kind of systems. There are the system integration problems behind the APIs, tools that you can connect to these agents, and also all the stuff related to the developer experience. So tools, debug, monitoring, all the things that help developers not only build in the first place, but also maintain reliable, production-greedy systems, agentic systems. The first, I worked on Neuron behind the scene for about 6-8 months across the end of 2024 and the beginning of 2025. At a certain point, I understood that the tool I was creating for myself was so good that I had the opportunity to share this project as an open source framework for the entire community. And in March 2025, I released the first version of Neuron AI. It was quite a success, if I can say. And I think there are two main reasons that drove the initial traction of this project in the PHP community. The first was because I finally designed this agent entity. So later in the talk, I will show you all the code, all these kind of components, entities. So I now just give you the story, and then we can jump into the code. So the ability to have this agent entity that you can configure with tools, system prompts, memories, etc., in one place, one cohesive object with all the moving parts of these agentic components into a single place that live in one specific namespace into your application, and then you can run this entity wherever you want in your application. This was I think this design met really the interest of a lot of developers. And then the first, really most common pattern behind this agentic component, like structured output, the streaming. And it was the chance to start experimenting with the most advanced part of this architecture, that is, what the most of developers know from the Python ecosystem. It's the LangGraph, so the graph architecture, the workflow architecture that power the LangChain ecosystem. So I started experimenting with this architecture to understand rapidly that the graph design was really confusing. It requires to write a lot of code to define all the edges, connection between nodes, components. So I completely restructured this part of the framework, because everything else was just a refinement of what was built in the version 1. But the version 2 was the first version that started with a stable implementation of the workflow system that is really the core of this architecture right now. The workflow in Neuron AI is an event-driven system that I started to understand that it was something I have to push, to bet, basically to go all in to. And in fact, the version 3 that came into March of this year is completely based on this new architecture. This is workflow architecture. In Neuron V3, everything is a workflow. The agent is a workflow, the RAG component is a workflow. So these are a couple of numbers from the start of the project to today. We have more than 2,000 stars on GitHub, a lot of contributors all around the world, 500 key downloads, and a lot of activity on the GitHub repository. So I want to go straight to the most important point of this tool. Why build everything on top of this workflow architecture? This is something that makes Neuron AI a really unique tool in the PHP space. And I think without any previous experience in the PHP ecosystem to build this kind of framework of architecture, I basically had the chance to to start looking at what other ecosystems were doing and just rewriting the best of all parts of other ecosystem in the PHP way. And the solution that came from my work was this architecture. And the workflow, I think, it's perfect to be used to build this kind of agentic system for three main reasons. It's perfect to represent cognitive tasks. So you have, a cognitive task that can be made by many steps. Some steps can be agentic, so they can involve the action of an LLM. Other can be just transition point to data loading or other just pure PHP stuff. So you can basically mix all these different purposes into one single workflow. It's composable. It's composable because the workflow architecture of Neuron AI is built with nodes. Nodes that emit events. The events that is emitted from a node just decide what node should be run next. So in this way, you have this single piece that are just PHP classes, this node, and just composing these nodes, you are able to basically create any kind of complex or just simple and linear workflows. And most important, it's stateful instead of the stateless pattern that maybe it's more common for us as web application developer. This is something that requires a lot of, a bit of more attention by developers to really understand what this stateful system really means. Because the stateful ability of the Neuron AI workflow is what really allow complex patterns like the human in the loop that no other architecture in the PHP ecosystem supports right now. So just a couple of links before I start playing with the code. If you mind, I just will take, a seat because this table, the PC is so down. So I think I have the microphone, so we can just play with this. So the first things I want to the first example, is how to get started, because this is the first, question that came into the mind of people looking. I don't know if this. Okay, it's just delay. Oh, sorry, I'm looking also in the online streaming. Okay, and so the first thing I want to show you is how to get started. And how to get started, I strongly suggest you to don't look at the documentation at all. Because now we are living into the agentic world. So I recently released into Neuron AI a couple of things that allows you to start playing with the framework directly using a coding agent. You have two options, basically. The first is to use the skills. So the framework ships with a bunch of, let me give a bit bigger, with a bunch of agentic skills. I want to hide, close for one session, okay. The framework ships with these skills that basically are designed to help your coding agent have everything, all the knowledge that he needs to start creating code, reliable code to build, your agent with the framework. The second option, okay, you have all the instruction, copy and paste. Now we see an example. The second option is to connect the documentation, so this documentation that we are looking right now, as an MCP server to your coding agent. So the coding agent, Cloud Code, Open Code, is basically able to dynamically search into the documentation if you are asking something that the coding agent doesn't know how to do. But if you have some familiar with coding agents, the skills are the most effective way to tell your coding agent to play with the Neuron code. And I have a little video to show you just a demo. I registered a video because, making this stuff in real time with the Wi-Fi connection can be lost. So in just 1 minute, we can move forward the video just to give you an example. And the example is just this project that I have here in my editor, where I open Cloud Code. I use Cloud Code, and I give Cloud Code this prompt that basically describe, an agent that I want to build, a business intelligent agent using Neuron framework for a small e-commerce admin panel. And the agent should answer natural language questions about sales data by querying a SQLite database. Okay, so in the other point, I just give the Cloud Code some specs, you know, if about what I want to do to drive the coding agent in the right direction. I give you the name of the agent I want to use, so business intelligent agent, with the SQLite toolkit to talk with the database, and the agent script, because I already created a little of boilerplate, you know, to start playing with this agent. So when you finish, run the agent with a simple question to check if everything's work and to see if the agent runs. So this is basically an example of what I have done. Just copy and paste the command to install the skills into the project, so the Neuron skills. I install the Neuron tool creator, the agent creator. So okay, I close this. Okay, skills done. So now I start Cloud Code. I copy and paste the prompt into the coding agent. And now Cloud Code should start, okay, thinking, working, etc. So I move forward the video because since now it's just Cloud Code, you know, treating, writing files, tools, agent. Here is you know, implementing the SQL schema tool. Here is the implementation of the agent itself. Okay, fixing and testing a bunch of stuff. Bash commands have typed to the agent. Okay, here is trying to execute the agent. And to the end, it should. So it's just one prompt. Okay, just one prompt session. Okay, and it's done. Okay, the result of this video is this code that I have here. So this is the business intelligence agent that Cloud Code created. You have the Anthropic provider, so it's basically the way in Neuron AI you have the AI provider components. You can provide every AI provider supported by the framework. There are a lot. You have not only AI provider in terms of LLM text interface, but you have also the audio provider to, you know, text to speech, speech to text, also the image providers. You can, you know, generate images and edit images on prompt. Then there are the system instructions that basically tell the agent you are the business intelligent assistant. That is basically what we asked to build to Cloud Code. And the SQLite toolkit that basically contains, let me make it bigger, two tools. One is the schema tool, that it's basically a tool that allows the agent to, the LLM, to understand the database schema, so it can next run a select query on top of it. And now we can test this agent. CD git Neuron. I call it Neuron BI instead of AI. So I call PHP agent. I think it's can make it bigger. Okay, and full screen. So PHP agent. What are the top 3 categories of products? And we should see the streaming of the agent response Wi-Fi. Okay, here it is. It's calling the SQL, the schema tool to understand how the database is created, and then call the select query to running actually the query on the database, and then return us the response. So now, if you want to iterate on this project, I can run code again and ask add the file chat history to the agent in a directory named history. Okay, so now I'm asking code to add a new component to the Neuron AI agent. That is the chat history. So basically, we are giving the agent memory. Okay, we let this work, and in the meantime, I want to show you this part of the documentation. So Neuron AI has this component, the chat history, that basically allows you to automatically retain the messages part of a specific conversation that you are taking with the agent. And this chat history component can be backed by many different storage systems. So you have the in-memory chat history, file chat history, that is basically what I told the code to use, that store all the list of messages into a simple JSON file. Or you can connect a database to persist these multiple chat you can have, for example, associated to a single user, to a product, or to an organization. It depends by the design of your application. So looking here, I think the Wi-Fi connection doesn't help us a lot. It's dire code. Explore 27 tool uses. I think it's exploring, using the skills. It's exploring the framework code to understand the file chat history component, the API. Okay, here it is. Find file chat history API usage. So in this way, using Cloud Code is my really suggestion, because you don't need to ingest the entire documentation in your mind. You can really start easily playing with the framework, with the coding agent, and then eventually exploring the documentation. You can, deep dive gradually in all the concepts about the framework at your pace. So it's exploring basically all the code base. And I think we should have quite done here. This is the toolkit. No code written. Hope it can go faster to the point. Oh, sorry, it's hanging around. Yeah, looking at the documentation, the file chat history should result basically in this snippet, where we just give the component the path in the file system where you want to store all the chat files. The thread ID is basically what allows you to store multiple conversations separately, so to keep all the threads in single conversation, in single files. And the context windows is, the unit of measure about the size, the maximum size that you want to retain the context. And the beauty of this chat history component of Neuron AI is that it works with tokens. The unit of measure is tokens, not number of messages, because tokens is the real unit that also used by the underlying LLM to understand the size of the chat history, the number of messages that you want to retain. Once you start iterating on the same conversation, when the chat history reach the maximum size in tokens, the component automatically cuts the older messages in the conversation, just retaining the token size that you configure here. Okay, allow or edit. Okay, here it is. It recognizes how to add the file chat history to the agent. So we should see here the code. Here it is. So we added with 50,000 token right now, but it's okay for our example. Okay, it had deletes. Do you work with coding agent too, or is something? Yeah, I think. Okay. Okay, that's it. So exit from here. And now what I can do is to ask the agent, do you remember what are we talking about? So now we are starting a new session from scratch. So basically the agent doesn't have any, shouldn't have, any idea of what we can. I don't have any previous conversation. So we can run the exact same prompt we executed before. He called the database, extract some data, provide us with the response, and then I can basically ask again, do you remember what we are talking about? Okay, it's a typo, but for AI, it doesn't matter. They are smarter enough. And now the agent, yes, we are talking about e-commerce shop and et cetera, et cetera. So now the messages we are exchanging with the agent are in the memory, in the context of the agent, automatically managed by, these framework components. Okay, so I want to switch to another demo project where I want to give you a couple of other examples of what you can really do with such an architecture. We can get bigger, see GitHub demo, I think we are here. And, I created this kind of demo project with a bunch of there are a couple of scripts just to give you an example of all the nuances behind what this kind of system can really do inside your application. And, the tool call pattern, I think is something that, maybe you are really saw in a lot of example on YouTube. It's the most common pattern when you build this kind of agentic system. And in Neuron is really simple because you can just use this tools method inside the agent that return a list of tools that are basically PHP functions that you can, oh sorry, I make it also bigger here. These single tools are, at the end of the day, they are invocable classes. So it's a neuron that just take care of transform all these tools into the JSON schema, inform the LLM about the tools he have available, and then decide what tools the LLM want to call. And this is the framework that automatically recognizes all this stuff from the LLM response and call the tool that the LLM want to execute. Return back the result to the LLM and then generate the final response. This is basically the tool call pattern that I documented here in the documentation. It's basically a loop. So the LLM can ask to call multiple tools during the same session until it decides that it's the time to provide the final response. But with Neuron AI, playing with the Neuron AI components, you can start creating something smart. For example, the tool search component, because one of the most common problems of developers working at building these kinds of system is the system integration problem, because they very rapidly start attaching tons of tools to this kind of agent, you know, CRM, APIs, MCP server to do all the stuff with external systems, and it rapidly becomes in you know, 100 of more tools connected to the agent, and the agent should carry all this payload of hundreds of tools back and forth to the LLM. And this problem also increase the chance of the LLM to call the wrong tool, because a lot of description, maybe they are similar in the meaning of the tools that are just slightly different. So the LLM can also call maybe the right tool, but with wrong parameters. So we need a way to hide this complexity in the first place to the LLM, but let the LLM to find a way to retrieve dynamically the tools he needs to perform the task. So with this component, we don't need to attach all the tools we have directly to the agent class, basically here. We just attach the calendar toolkit. Instead, a lot of other tools are just provided as a constructor parameter of this component, that it's basically the tool pool. So all the tools that we want to make available to the LLM without carrying statically all the payload back and forth on every request. So we provide this list of tools to this component. What happens? I designed, you know, a prompt just to force the agent to call a bunch of tools to allow you to see this mechanism in place. This component dynamically inject into the agent, let me find where it is. Oh, here it is, the tool search tool. You know, so this basically one tool, so the LLM will see just one tool that is able to search inside the tool pool, so the list of tools that we are giving behind the scene to the agent. So I think it's more easy to see how it works. Then speaking, so PHP public, I think it's the first script tool, and we'll see it in action. So it received our prompt, the message that I showed you before, that basically force the agent to run a bunch of tools, and some reasoning, and then he start call the tool search. So let me see what other tools I have available, and he finally found the square root that isn't attached on the agent in the first run. It's able to automatically discover this kind of additional tool dynamically. And if I refresh here, I think we can see into the monitoring system this mechanism in place. This is the tool search that the agent executed with this query. So it's basically searching inside the pool, and the tool returned back 10 tools that were automatically attached to the agent for the next run. So now the LLM can see these 10 tools extracted dynamically and can decide if in these 10 tools there is what it needs to finally provide the answer. So back to the slide. If this sounds interesting to you, I also wrote a book about all these pattern architecture, and it was the result of my learning in the last 2 years working on this project. And I would be curious to know if you have some experiences, or maybe you had the chance to play with this architecture, maybe using other programming languages, because before Neuron AI, it was just possible with Python stuff. My goal was basically to make Python no more a choice for the PHP developers. So we are building a vertical ecosystem. Feel free to give me your questions if you are curious about some stuff. We can go deep into some aspects if you want. That's it from me.